Hi and welcome back. This is class 11 in which we are going to further improve the simulation. From my experience, the most important part of a simulation is the emission. So we are going to further complexify our emitters and inject some noise in the velocity. And then we'll see how to use some masks and fields to assist us in this process. So dive back into the wall emitter geometry here, and we are going to visualize the speed first because there is something I want to do here. I would like to add some improvement because right now the speed is really on and off. Okay, if the speed is above the threshold, then it starts emitting. If it's below the threshold, then it stops emitting. It's either 0 or 1. And I don't really like this. I want something progressive. Okay, so I'm going to do this following thing, emit equals, and I'm going to fit the actual speed between 0 and the threshold that we get, and going to do that between 0 and 1. So now when we actually start moving, we have a velocity that goes from 0 to threshold. It will be between 0 and 1, and after threshold, above the threshold, it will stay at 1. So the emit will stay at 1, but we will have something progressive between 0 and 1. Okay, so I'm getting rid of this, update emitter controller attributes, that's good. And now you see that some of them have changed, and we have some gray value. Let's look closer. Okay, you see we have some intermediate values here. Before that, it was all either black or red, and now I have some intermediate values. If I increase this threshold, then I have even more variation here, and it's going progressive. So 31, and then it moves, and then it increases and reduces. Okay, so I think I'm going to go with this and this threshold. Maybe I'm going to get lower. Okay, so at least for the speed now we have something a bit smoother than before. Now, still working inside the wall emitter, go to the density final node and display its velocity. And this is what we have right now. Okay, so the velocities that are going to be rasterized and sourced inside the simulation are quite linear and straight. Okay, and this is not going to help us giving some interesting motion. We need to add some noise here to give some eddies and to give some to vary the emission of the velocity inside the simulation so that in turn it can add some eddies and turbulence and vorticities in there. Okay, so we need a mess at the emission to be able to get the sourcing a bit more interesting. So to do that, I'm going to, well, we have two options. We can either use the attribute noise here or the point velocity, that node that is dedicated to actually tweak the velocity. So either here you decide to come here and you define a noise. So I'm going to drag it here, show the noise here. I'm going to noise the velocity, increase the amplitude here. You can vary the amplitude per component, and then here you can reduce the element size, and you see we can already have some noise to velocity, okay, instead of the straight one. So you can tweak this one, but I'm going to choose this one because we already have seen the attribute noise. So the point velocity here, first thing, go and do a set value. So you could do a keep incoming. Okay, so it will keep the incoming velocity, and then you would add some curl noise to it, and you can increase the scale, and it will give some interesting shapes to the velocity. But what I would like to do, and the problem I have with the velocity point velocity here, is I would like to add this noise only where the fragments are moving. And right now it's adding the noise everywhere, you see? Here we don't have any velocity, but it's still adding the noise, and I don't want that. So to do that, come here, put it to set to value. And this way, if we have a default value of 0, we only have this curl noise, which is created here. Okay, so V here would be only the curl noise. All right, and then we are going to add this velocity to the main velocity. Now, before doing that, I realized there's a lot of attributes I didn't clean. Sorry about that. So I need to clean them here. I don't really need the color, I think. So I'm going to get rid of this. The ID I need, the N I need. Okay, so I'm going to get rid of the color. Point. Why do I color? Where's color? Oh, it might be here on the point level. So I want to remove CD because I don't want to transfer it. Though it is still. Okay, how do I? Don't want CD. Okay, and I don't want you, so get away. Okay, so it doesn't want to remove it here. All right, so I'll do it after. Attribute delete. Fine, this happens. So I'm going to do it here at the end, just before. Okay, so I keep all the normal and all the things that I've done here. And here I'm going to delete everything, but I want to keep the velocity. So, you know. All right, so we just have the velocity here. And now we can play with this. Yes, one other thing I would like to keep is the rest position. You remember, we use the rest position to have a static noise on each fragment, okay? And then we can control the actual movement of the noise with this pulse duration. So if I do a time shift there, and I freeze this to frame 72, and then now I can play, and we see that the noise is moving with this speed. So maybe I'm going to put that 4, maybe 5, so it doesn't go that fast. Reduce this noise maybe a bit, and the swirl size, I'm going to reduce that to 0.4. Let's have a look here. Maybe a bit more. So we have some really chaotic noise here. Maybe I'm going to increase that a bit, too much. 0.5. Okay, and now I have this. I want to add it back to this. So attribute wrangle, okay, and I'm going to add this one on the right side to the one on the left side. So we have V here. We are going to add it here, but we want to add it with how do you say, a weight, and the weight is going to be the actual speed. So I need to get the speed. Float speed equals length of V. Okay, so now I have the speed here. And what I would do is V plus equals, so we add something to V, and we are going to add the one from the right side. And I don't know if you know this expression op input 1, so we get the value from the first input, well, sorry, the second input, so 0, 1, 2, 3, so 1 is the second input, and we say V. All right, so if I do that, then you see we are adding the noise. If I don't do the plus equals, then we have the same noise as here, okay? Here we have the color, so I'm going to do this, okay? So we have the same noise as this one, but now if I do plus equal, then I have I have the noise added to my velocity. But I don't want the noise here, so I'm going to multiply by the speed. Okay, so it gets bigger, obviously, but you see that when we don't have any speed, now the noise is 0, and when it's moving, we have something. So if I go back here, you see we have no noise, and then when it starts moving, it's adding the noise. So maybe now the noise is a bit too big. So either you reduce it here, something like this, or here you can even add some percentage multiplier, so you even reduce it here. Your choice, okay? I give you both options. And now here it's like the noised, okay? And this is how we build the noise, and that we are going to inject inside the sourcing. And so we have two ways to add this velocity inside the simulation. The first way would be to add it as before inside the rasterize here, okay? And it would be cached with the main velocity. And that's the problem with this method, and I don't want to use that, is that the noise is mixed with the main velocities. This is what we want in the end, but the problem is if we cache that with the main emitter, with this velocity here that we have, with this velocity, the problem is that if I want to increase the noise separately from this, then I won't be able to do that inside the simulation directly. Okay, so everything would be in here, and if I want to increase the noise by 10, and I do that, then the other velocity, the main velocity from the fragment, is going also to be increased by 10, and I don't want that. So what I'm going to do is I'm going to separate this into a second branch, okay, here, and I'm going to add this noise into a separate volume. So to do that, copy paste. Okay, so I'm going to rasterize this, but I don't want to rasterize added to the original velocity, so I need to use this only. All right, sorry. Okay, let's get back to this. And now, so point velocity V noised is here. Okay, so now I need to change this, but I still need the speed because I want to modulate, sorry, the velocity by the speed. So I'm going to say, okay, my velocity is going to be modulated by the speed, and the speed I need to calculate it from this side. Okay, this is where I get the correct speed. So I need to here say calculate the speed from up input 1. Okay, and I multiply. If I don't do that, let's do that. Okay, I comment this out. If I don't multiply by speed, I have noise everywhere, you can see. Let me increase this. Okay, and if I do come here and add the multiply equal speed, then I have the speed, the velocity only where the speed is greater than 0. Okay, so it's modulated by the speed. And now I have my correct velocity. V, I also have rest, but I don't really care. And then I rasterize, and I don't want the density. And so to check that it's actually working, volume trail. Okay, we need points. We have points here. We need a volume. We have volume here. And if I display it, hiding this, then we have the velocity correct. Good, so now hide this 16-bit, then this is good. Then I need to cache that. I'm going to call that V noise. Okay, so that's the noise from the velocity. I should have copied that with the with this. So I'm going to need to change the name in here. So it's not volume, it's V noise. Now it's referencing the correct one. That's good. The render, I don't need that. And okay, now this branch is coming here to the density final, and don't really like to have this here. So I'm going to separate it here, okay? And I'm going to branch it here, and same here, this should go here, okay? Let's check this is still working. If I go here and display the noise, okay, we still have something fine. All right, so I'm going to do a little bit of cleanup here, okay? And I'll be back in a minute. Good, so this is all cleaned up. Now, in the meantime, also, when I was offline, I cached my emitter. So now I have it cached here correctly. And if I go to the simulation network, now I can come here. And I'm going to duplicate this, and I'm going to call that wall V noise, okay? Obviously, here the naming falls short, okay? So the expression is not working. I need to call that wall emitter, and here it would be out V noise, okay? It's fine. I don't have any density, so I get rid of it. And now I have the velocity, and I can add it here. Either I move that so it's actually in the, close to this, to his friend, but maybe I'm going actually to merge them so visually I know that they are working together, and it's a bit better for me. And so here I have my emission with the main velocity of the fragment, okay, and I don't really want this to be above 1 unless this is helping the look of the simulation, but I don't think it will. And here I can add the noise now in a separate way. Of course, I will only be able to work on the amplitude of this noise in the emission and not the frequency or the pattern, But anyway, this is still better than having everything mixed inside the main one. And now, well, let's do a simulation and see if it's actually working properly. So I want to, okay, yeah, I want to use a division size which is not too low, too big to actually see the pattern, and obviously not too low, so it's still going fast enough. But now is the time when we leave this one and we start moving to something a bit more defined. So maybe 0.7, maybe 0.6. I'm going to start with 0.7, the one I used before. Here I have one. I'm going to put a noise of 2. Okay, fine. And then I'm going to activate the solver and rewind, get into my camera. And I'm going to do a flipbook, and I will be back when it's done. So I made this flipbook first without the noise. Okay, inside here I deactivated this node just because I wanted to be able to compare this version with the one with the noise. And so for that I'm going to use a feature of the image viewer. If you go here, you can create a new sequence, and now any new flipbook that you are going to do is not going to override this one. It's going to be created as a new sequence. And so this is the new version here. So to compare it, you can bring the sequence list, and then you can come here and compare both of them. I need to pause here. And as you see, so we have something different, all right? So something is actually doing what it should do, but it's hard to see if it really added noise or it's just changed the simulation, because the resolution might not be big enough, or the render not precise enough here. So what I'm going to do is I'm going to do another version with more amplitude here, more scale in the velocity noise. And then probably what I'm going to do is render one of them or two of them to be able to compare them side by side. So this is a new version with this time an amplitude of 10 on the emission. Okay, the scale of the velocity is now 10 instead of 2. And this is what we have. So definitely a little bit more chaos or noise in there. You can see that it's actually doing something here, but still I would like to render that. So I will launch some renders and I will come back when they're ready. And so this is a render with no velocity noise inside the simulation. Here v noise equals 0, okay? And you see that we have some flat areas here. We have something, but it's not really interesting. It's a bit dull. And now if we go with velocity noise of 2, this is what we get. We get some more movement in there, some broken up trails here that starts to be more interesting than with no noise at all. And now with a velocity noise equals 10, I mean the scale is 10, now we have even more shape in there. So maybe it's too much for what you need, okay, and you need something in between. But you can see that it's adding some interesting movement there, some more patterns. Even the trails here are more broken up. So we need more samples in the render to start to see them correctly. So maybe I will have to increase the stochastic transparency samples. But at least now with just this same render and this quality of settings, we see that we have a better quality of the simulation, so more interesting shapes inside the simulation. And they are exactly, all of them, exactly the same division size. Okay, it's the same resolution, all the simulations, really. So with just injecting some noise inside the velocity, we are having some more interesting movements and patterns in there. So that's why I personally think, from my experience, that the emission is key in the simulation. The emission is, for me, maybe 60 to 70% of the job, okay, of the look of the simulation. Then you will work on some fields and other stuff. But I think caring and taking care of your emission and the way you emit, density with the noise and the velocity with the noise is really something that will improve your simulation. So I did some work offline, and the work we did here to add some noise on the fragments, basically I did the same thing here on the track emission. All right, so I copied the branch and I adapted a bit the noise. If you want to see the actual velocity, let's display the velocity, and this is what we have. Okay, so first we have those velocities on the track, okay, really linear. And then if I create the noise here and add it with the speed to the original velocities, this is what we have. I use this really as a visualizer to control my noise and to see if it's giving me some nice shape, but it's not used. The one I use is the V noise separated, and I cache this into a V noise volume. The same as before, really, the same as the wall emitter. And then I did the same on the debris emitter here, okay? So when you visualize this point velocity here, you see that I added some curl noise. I decided not to separate the V noise from the original volume because for the particles, I don't think it's really necessary to separate them. It's not too long to cache that, okay? It's quite fast actually. So really, if I need to change the frequency or the amplitude of the noise, I can come back and launch that in a minute. And then I added another emitter, okay, which is the terrain emitter. I wanted the debris, the fragments, to actually emit some density when they were hitting the ground here, especially here, but also here. So to do that, I went inside this terrain emitter geometry, and I merged the terrain, okay, first. And I thought, okay, I need the fragments here to detect when they get into contact with the terrain. And to do that, I use the attribute transfer. So when the fragments are close enough to this geometry, okay, and close enough here is 0.05, then they transfer the velocity here. And when they're transferring the velocity onto this side, and this side, sorry, I forgot to mention, so I have the terrain here. I scatter some points, okay, and I initialize the velocity here, and so that when it gets transferred, all the points that have 0 velocity stay to 0, and then here the velocity gets transferred. And so if I display that, now you should see some of them here getting, and you see it here, getting some velocity. And then I create the emission according to this velocity. So if I display this, I see that I have density, which is built according to the length of the velocity, so the speed. And when the speed is between 0, 1, and 1, it gets progressively from 0 to 1. And above 1, it's 1, and below 0, 1, it stays at 0. So if I visualize, then I blast the points with the density, which is equal to 0. So I keep only the density, which is above 0. And if I visualize, I have, let me just get rid of this one. I have my points that are staying, which are having various red values there. And this is where it's going to emit. All right. And then it's just the same. I just cache that to a volume and use that inside the simulation here. So inside the simulation, I did the same for the track as before, okay, for the wall emitter. It's just two things. The track emitter, I decided to activate it only all the way up to frame 35, okay, and then it stops emitting because I decided to activate it there. So here, the activation is 1 before frame 35, and after that it's 0, so it's not emitting any more velocity or noise. And I also linked the scale of the velocity emission to this one, so we have the same base, and then I multiplied it by 5. And here the terrain emitter is just the same as usual. It's emitting from the terrain volume, and it's emitting density and velocity here, okay? And so I did some render, and this is what we have now. To compare with the previous version, we have also this one, the V-Noise 10 from before. Okay, so this version was without any noise on the track, without any noise on the debris, and without any terrain emission here. And let's pause the video. Where was it? Frame 93. this is what we have. So we have quite a difference with just the noise from the truck. Obviously, we have some density here now, which is adding to the realism. And if we look at the moment of the impact, okay, this is what we have. So we broke up even more the moment of the impact thanks to the noise from the truck. All right, and now let's see the actual simulation side by side. And this is what we have. And so to sum up what we've seen in this class, if you have something to remember from this class, this would be that the emission is key in the look of your simulation. You've seen how much detail we could add with just playing with the noise on the velocity emission, and all this with the same resolution of the pyro object. Okay, so really take good care of your emission, play with the velocity noise, and this will help you big time in making your simulation look good. Now, another thing here is inside the simulation network, you can separate the main emission from the noise. Okay, so you can work on the noise and increase this without having to change the main emission. I would say that once you're done here, okay, once you know that you have the correct proportion of the noise as comparison to the main emission here, the main velocity, you should go back to your main emitter and merge back with the same proportion the velocity inside the initial velocity. Why is that? Well, it's because it takes more time to compute two emitters than one. Okay, so while you are still doing some tests and tuning the noise as compared to the main emission, you can stay with this. It's fine. You play with the values. You maybe even add some more emitters. But once you know that, let's say this is good for you, okay, a scale of 10 as compared to a scale of 1, go back to your emitter, okay, and you use this to merge with the main velocity, and you multiply by 10 this one, and you merge it with your original velocity, okay? And then you cache it, and obviously when you come back here, you delete one of the emitter or you deactivate one of them. And that way you have only one emitter, and this saves you some time during the emission. So when you are going for the final resolution of the simulation, then you would go a little bit faster. It's not a big time saving, but it's still this that you save from simulation. And also here, and especially if you have 2 or 3 emitters that are split up between the main and the noise, you should do that as well. All right, and I think that's it. All right, good. Well, thank you for watching, and I see you in the next part of this class. Goodbye.